Okay, let's give you guys some practice now. So here, find the limit of this function here as x approaches positive 6. Okay, so if you try and graph this function here, it will look like this. It will look like this. And as you approach positive 6, that's you from the left-hand side here approaching positive 6 here. And then from the right hand side, you will approach positive 6. It's actually undefined at here at precisely 6. So here, if you try and plug 6 into here, put the 6 into here, and into here, and into here, it will give you 0 over 0, which you can't really deduce much from it. So, well, find the limit of this here. So press pause and have a go. Okay, so to do this here, try and factorize, because when you try and there are lots of small techniques that you use to find the limits of something. Here in this case, try to factorize. If you look at this here, you can factorize it as this. Well, this times this here, and well, these two here, they will kill off each other. They will kill off each other, leaving you just this. And now you can plug. Well, when these two cancel out, it will give you this here. Now you can plug the 6 into here without getting 0 over 0. Okay, so here when you put 6 into there, it will give you 6 over 5. So going back to our graph, hang on, going back to our graph here, you see this here, hang on, bear with me. This here is actually 6 over 5, precisely 6 over 5. Okay, so now the next question, hang on, the next question is this. Given this here, now this time find the limit as x approaches 1, positive 1. Okay, so press pause and have a go. Okay, again, to do this here, you could factorize it. So this whole function here becomes this, and then these two will cancel each other out. Okay, so this function is an exact same function as the earlier one. So these two will cancel each other out, giving you this. Now when you try and plug this into here, you will have 1 over 0. You see, earlier we had 0 over 0. This is indeterminate. So you can't really deduce much from it. This one here, this one is a definite limit. Remember, here you've got to use that theorem where if this is a definite limit other than 0, and this limit here is 0, then you can say the limit here does not exist. Okay, so this is us using that theorem. You probably have to scroll back and have a look at one of the early videos. But there's a theorem that says whenever this here heads towards a limit other than 0, and this here heads towards 0, then overall the limit here does not exist. And if you go back to our original graph, hang on, our original graph, bear with me. Going back to our original graph, so the question here, hang on, the question, oops, hang on, bear with me. The question here, the question here is saying, well, find the limit as x approaches positive 1. Well, positive 1 is here. You can see there's an asymptote here. From the left hand side, it approaches minus infinity. From the right hand side, positive infinity. Here you can see here from the graph that the limit does not exist. Okay, well, the first question was find the limit as x approaches 6. The second question was find the limit as x approaches positive 1. When x approaches positive 1 here, positive 1 is here, the limit here, limit does not exist. Okay.